So we're going to solve some one-step equations. So this is an introduction to solving equations. And the reason I put the equal sign down here is because you need to understand that the equal sign represents that one side is balanced with the other side. So we think of like a scale in science class, and they have to stay balanced. So as long as they stay balanced, we can manipulate the equation so that we can get x alone. So the whole object is to get x alone on one side. And if we can, then we'll know what x is equal to. And x will be equal to our solution once we get it alone. So that's why we say we solve. So when we look at this first problem, I'm going to draw a line so that it acts like the two trays on the balance. So it's balanced. And I want to get x alone. Well, I'm going to change this minus 5 to plus a negative 5. Because if I can get x plus 0, then that means x is alone by the additive identity property. So if I add the additive inverse to 5, negative 5, which is 5, I'll get 0. But if I'm going to add 5 over here, I have to add 5 over here. And 27 plus 5 is 32. And over here, I've got now just x plus 0, which is x alone. And so, bring down my equal sign, x is equal to 32. So to check that, it's always a good idea to check. Then we're going to take our original equation, 27 equals, and it's x minus 5. And we're going to put 32 in for 5, or for x, what am I saying? And we're going to see, are both sides really equal? So we have 32 minus 5. This side is 27. 32 minus 5 is also 27, so it checks. Now the do-undo chart is just a way to simplify it if you don't understand this way, but you should understand this way from our properties. But when we look at the equation, what are we doing to x? That's what the do stands for. And we're subtracting 5 from x, so that's where we put the do. The undo is just the opposite, so that would be to add 5. So if we add 5 to what is really a negative 5, because that's like adding negative 5, and we add 5 to both sides, then we get 32. And again, negative 5 plus 5 is 0, and x plus 0 is x alone. So we have x is equal to 32. Just another way to do it. The next one, example 2. Now this time we want to get m alone. And so I'm going to draw my line for my balance. And I've got m added to 14. So what I'm really looking at is the sign 14 is positive. And I want to add its additive inverse, which is negative 14, so that I'll have 0. And then m plus 0 will be m alone. But if I'm going to add negative 14 here, or subtract 14, I'm going to have to do the same thing to this other side. Well, think about 14 bad guys and 5 good guys, or 5 positives. These 5 positives combine with 5 of these negatives and give us 0. So then there's going to be 9 negatives left. So my answer, bring down my equal sign, will be negative 9. So when I go to check that, I'm going to substitute in 14 plus, and I'm going to put in negative 9 for m, and I'm going to put a question mark here. Is that equal to 5? Well, 14 minus 9, or 14 plus negative 9, is 5. So both sides are the same, so it checks. Okay, so for example 3, now it's multiplication. Well, we also have an identity property of multiplication. If I could get x times 1, I'll have x alone, and that's what I'm trying to get. Well, if I've got x times 14, and I want to use its multiplicative inverse, then I would use 1/14, which is the same thing actually as dividing by 14. So like over here I could just do divided by 14. And here 14 over 1 times 1 over 14 is going to be 1 over 1, which is 1. And 1 times x is x alone. And over here 98 divided by 14 is 7. And again, when you go to check it, 14 times 7, we think, does that equal 98? If you do your distributive property, 7 times 10, this 1 is 10, 70. 7 times 4 is 28. 70 and 28 is 98. So both sides are the same, so it checks. Here for the do-undo, we say multiply by 14, the x, so we divide by 14. Multiplying by 1 over 14 is the same thing. Same thing as dividing by 14. Okay, if you'll turn your paper over for the next example. Now we have 8 equals x divided by 15. So x divided by 15, remember, would be the same thing as 1/15 times x. So I would multiply both sides by 15 over 1, or just 15, both sides of this equation. Because if I take 15 over 1, the reciprocal of 1 over 15, which is really this dividing by 15 is, those 15s will divide out and I'll get 1x. So divide out your 15s and you get x times 1, or x alone. On the other side, 8 times 15 would be 80 plus 40, which would be 120. So to check that, we'll say 8 equals 120 divided by 15. We want to know, is that equal? And 120 divided by 15 is 8. So it checks. All right, and our last example is 2/3 times x equals 14. Oh, can I go back here just a minute? Okay, for the do-undo, we're dividing by 15. So I'm going to put divided by 15 there. So the undo, you multiply by 15, which is what we did, which is the same thing as 15 over 1. Okay, so then example number 5, we want to get x times 1 because we're multiplying, so the multiplicative inverse will be the reciprocal, 3/2. So we're going to multiply 3/2 on both sides. So the 3's divide out and give me 1. The 2's divide out and give me 1. 1 over 1 is 1, so 1x is x alone. On the other side, we're going to put 14 over 1. We could divide out a 2. Divide a 2 out of 14 and get 7. 7 times 3 is 21 over 1, which is 21. So to check that, we'll say 2/3 times 21, which is x. Does that equal 14? So we put 21 over 1, divide a 3 out of the denominator, a 3 out of 21 and get 7. 7 times 2 is 14 over 1, which is 14. So we do have the same thing on both sides, so it's equivalent. Now, on the do-undo, you're multiplying by 2/3. Let's multiply. Multiplying x times 2/3. So to undo it, you would divide by 2/3. Well, remember, when you divide by a fraction, that is the same thing as multiplying by its reciprocal, which is exactly what we did here and here. Okay, that's the end of that video. So if you'll do your solving one-step equation practice,